and welcome to our next video. Today we discuss about the complex number. This is one request from my one student or one my subscriber. So I give you the lecture on the complex number. Here we define how complex number were generated and what is the meaning of complex number. So when we go for the number systems, there are many types of number system: whole number, rational, irrational. Then we expand the theory of that number system for the negative numbers. Then we go, first one is the integer. Integer means positive numbers, negative numbers and zero, whole numbers. We talk about if all -1, -2, -3, 0, 1, 2, 3 up to infinity. These are called integer. Next is the rational number. When we talk about the rational number, all integers and all factors. Now we go for factors. All fractions, these are rational. And irrational number, the number which can be repeated like under root 2, under root 3, these are the irrational number. When we mix this rational and irrational number, this theory of all numbers is called real number. So our number system stops here. But when we go for finding the roots of quadratic equation or any equation, quadratic is the basic equation, is square root. So when we find out the roots of that quadratic equation, then we stuck. We cannot able to find out the roots for some equation. Like one equation is x square plus 1 equal to 0. If we want to find out the roots, then x square equal to minus of 1. Minus of 1, when we take the under root, x is equal to minus of root 1. When we go for this negative square root of negative numbers, then we need one another system that's known as complex number. So from here, when demand will come with real number, we cannot find out the roots of these types of rational number, then we go for this complex number. Then what is the definition of complex number? A complex number is defined by a pair of real numbers. Complex number is defined to be a pair of A, B real numbers subject to follow the rules. So this A individually and B individually both are real number, but when they combine with some rules, then it gives the image that complex number, and it followed by some rules. So what are the rules? I can discuss here. Okay, so first one, number 1 is if Z1 is one complex number A, B, Z2 is another complex number C, D, then we can say Z1 equal to Z2 if and only if A is equal to C and B is equal to D. Then only Z1 complex number is equal to the another number. One more important thing, that complex number given by two parts A plus iota B. A and B are real numbers. Iota is the notation of imaginary. So this part is called real part of given number and iota B is called imaginary part of given number. So if we can say AB means this is A plus iota B, if we say CD means C plus iota D. So these types of number. Next, what are the next rules? If first one, if Z1 we can say if one complex number is equal to other complex number, then follow this rule. Next, if we add two complex number, some theory are same, but some may be different. When we go for the multiplication, it is entirely different from the real number. So second one is the, if we can say z is equal to a comma b, z2 equal to c comma d are two complex number, then addition of these two numbers is addition of real part of both number plus addition of imaginary part of both number. So z1 plus z2 is given by a plus c comma b plus d. This is our addition. Real part add with real part, imaginary part add with imaginary part. Then third one is the multiplication. If z1 is this, z2 is this, then z1 multiply with z2 is given by little bit different ac minus bd comma ad plus bc. So real part coming with this and this is imaginary. So what a multiply with c minus b multiply with d is real part of multiplication of this number, comma means plus iota, then imaginary part given by a multiply with d plus b multiply with c. So this is the multiplication rule you have to follow. When you multiply any two numbers, you have to follow this rule. For example, if I have z1 is equal to 1 plus 2 iota, z2 is equal to 3 plus 4 iota. So I can say 1 comma 2 and this is 3 comma 4. So what is the multiplication of z1 or z2 is equal to a into c. 1 into 3 is 3 minus 2 into 4. 2 into 4 is 8. So this is 8 comma ad. 1 into 4 is 4 plus 3 into 2 is 6. So new number is minus 5 and 10. So what is our new multiplication of these two numbers is minus 5 plus 10 of iota. This is the multiplication of 1 plus 2 iota and 3 plus 4 iota. So multiplication follow always this rule. Then we can say in complex number we talk about this iota. So what is this iota? Basically iota is a real number, or we can say iota is a complex number given by 0, 1. 0, 1. So iota is a complex number given by 1 and value of this iota is square root of minus 1. You should always remember this thing. Then value of iota square is equal to 1. This is another important value for this, and we know in always every complex number have two parts. One is real part, another one is imaginary part. Real part without iota part, imaginary part with iota part is imaginary part. Next, if we talk about the laws of our algebra of real number, which laws? Associative, community, linearity property. Then how it goes with complex number, there I will explain you. If you want proof, you can easily find out all the proofs in the your books, and you can just take any example of two numbers and you follow that law of multiplication addition. You can easily proof of that laws. So what are the laws of algebra for complex number? Laws of algebra for complex number. First one is commutative law. If z1 plus z2 is equal to z2 plus z1, both value gives same. What is the meaning of this? This law is called in algebra commutative law of addition. Similarly, here Z1 and Z2 are any two complex number. Z1, Z2 is equal to Z2, Z1. Commutative law for multiplication. This is for addition. This also follow. Third one is the associative property. Associative property is what? Z1 plus Z2 plus Z3 is equal to Z1 plus Z2 plus Z3. Associative law for addition. What it means, if we have these three complex number, first we add this and then the required result add with this number is same. First we add first two numbers and the result add with this number gives the same result. Similarly, multiplication case, associative law also follow the same. So Z1 dot Z2 Z3 is equal to Z1 Z2 dot Z3. First we multiply these two, then multiply with first one, or right hand side first second multiply, then multiply with the third number. Both answer are same. So this is the associativity of complex number, means commutative law for addition and multiplication and associative law for addition and multiplication follow in complex number case also. Next is the last one is the distributive law. Distributive law is Z1. Law of addition and multiplication combined is Z1 Z2 plus Z1 Z3. This is the distributive law in algebra. If we have Z1, we add these two numbers and multiply with this number is same like multiply these two number, multiply these two number and add it. So this is the distributive law of complex number. You can prove all the laws with consider the general form. Z1 is equal to AB, Z2 is equal to CD, and follow the rule of addition and multiplication. You can easily prove all the laws with the help of complex algebra. Next, we go for the negative of any complex number. Okay, so negative, then inverse of complex number. So first one is a negative. If Z is our any complex number, then its negative is the minus of Z. Negative of complex number. So what is minus of Z? If we can say Z is A comma B and minus of Z is any another number is X comma Y, then in real case, if one number is 2 and its negative number is minus 2, and addition of 2 and minus 2 gives result 0. Clear? Similarly here also, if we add Z plus of minus Z, it gives 0 comma 0, or we can say AB plus XY gives 0 comma 0. Clear? Where Z is non-zero number. It is non-zero number. If it is non-zero number, then definitely plus means A plus X. This is negative value of this. It gives 0. B plus Y gives 0 value. Definitely, if gives the 0 value, then minus Z is the negative number of given Z. Clear? If it is negative number, then next one is the inverse of Z. Inverse of Z is 1 by Z. Clear? So what is, if we talk about the real number, if 2 is real number, then its inverse number is 1 by 2. So 2 multiply with 1 by 2 gives 1. Always any number multiply with other inverse number gives value 1. So same follow in complex number. Z multiplied with 1 by Z gives identity element 1. So we can say this is Z of minus 1. So we can say Z is equal to A comma B and Z inverse is X comma Y. Then result is A comma B multiply Z comma z inverse is equal to 1 comma 0. So multiply with x comma y gives 1 comma 0. If it gives value 1 comma 0, then z inverse, this is the inverse of given number z. Clear? Next is the difference. In previous we can talk about addition. Addition of two numbers is first real part with real part, imaginary part with the imaginary part, and we talk about the multiplication. Now we talk about the difference, subtraction and quotient, division, because without negative number of real number, complex number, and without inverse we cannot talk about the multiplication, division and its subtraction. So now we go for subtraction. If we talk about the subtraction difference, z1 is equal to a comma b and z2 is equal to c comma d, then z1 minus z2 is given by z1 plus of its negative number. So this is this. First we have to find out negative number of this and then same rule of addition. So here we need the negative number. Next is the quotient or division. Third and fourth operation is the quotient. z1 divided by z2. So if z1 and z2 are two imaginary number, then first we have to find out the inverse of z2, and then z1 inverse of z2 multiplication is same as this, where condition is z2 is non-zero number. It cannot be 0. If it cannot be 0, then its division given by, first we have to find out its inverse and then multiply with this number. Clear? Next is we talk about the conjugate of complex number, conjugate numbers. So what is the conjugate number? Complex number. If z is our number a plus iota b, then its conjugate complex we can note it by bar, and given by z bar is a minus iota b. A and b, its combination of real numbers a and b, real numbers. Then for z and for z bar, real numbers are a and b. So this is called, z bar is called conjugate complex of z. Again, if we want to take its conjugate, then z bar of bar is again z, a plus iota b. So this is called conjugate complex of the given number. So for this conjugate complex you can solve many properties, you can solve the many problems. Like first one is the, if we can say z1 plus z1 conjugate complex, if we add these two, then we can say 2 times real part of z1 result is. If we can z1 minus z1 bar conjugate complex, then we get 2 times of imaginary of z1. 2. Clear? Add this real with real, a plus a, 2a, then comma b and b. So what is this? B and this is minus of b, because we consider plus here, negative. So b minus b gives 0. So this is new number is 2a comma 0. So 2 real part of z1, 2 real part of 2 times real part of. So you can prove very easily. Some more examples, some more results. Like if you want to find out z1 plus z2, then conjugate complex is the z1 conjugate complex plus z2 bar. Similarly, z1 minus of z2 is given by z1 conjugate minus z2 complex. Conjugate. These are the result for the conjugate number of complex. Next one is the modulus of complex number. modulus. Mod, you know, always if we can take modulus of any real number or any number, it gives the positive value. Okay, so in case of complex number, when we talk about complex number, modulus gives by these two, or we can say write like modulus of z. Modulus of z is an absolute value of complex number defined non-negative real number. Absolute value of complex number defined non-negative real number. Always modulus means positive number. So what is the modulus of z? If z is a comma b, or we can say a plus iota b, then modulus z gives by a square plus of b square. This is the modulus value of our given complex number. Clear? Then with the help of this modulus we can prove many results, like modulus of z1 is equal to modulus of z conjugate complex of this. Similarly, z1 multiply with its, then we find out the modulus of these two numbers is equal to z1 of square, and so many results you can prove with this property. So these are the modulus property. Next is very important, trigonometrical representation, or we can say when we transfer this complex number into trigonometry, sine theta, cosine theta. So what are the relation between this complex number and trigonometry? When you studied differentiation and integration, everywhere you can substitute x is equal to r cos theta when real number system, or we can say Cartesian coordinate is transfer into polar coordinate, x is equal to r cos theta, y is equal to r sin theta, and x plus iota y, or we can say r square is equal to x square plus y square, and so on. So what is this? This is the presentation of any complex number in trigonometrical form. So what is this? We can understand here. If we can talk, we have one point P, we have one is x plus iy, then this distance is y, this is x, this is our theta, and this we can say in our trigonometrical, this is radius vector r, or we can say this distance is r. Then now we discuss about the trigonometrical representation of our complex number. If P is any point of complex number, it is other than origin, it is not 0, 0. So if it is other than origin, our z, or we can say our complex number z is x plus iota y given by P point. Then if we want to represent this P in polar form, P in r and theta, then we transfer this x is equal to r cos theta and y is equal to r of sin theta. See here, x, or we can say cos theta. If we talk about the cos theta is equal to base upon hypotenuse. Base is x by r is equal to cos theta. So cos theta is x, x is equal to r cos theta. Similarly, if we talk about the sin theta is perpendicular by hypotenuse, then y is equal to r sin theta. So this given by this result. Next we go for if its modulus r square is given by x square plus y square. see here, if we squaring, then r square is equal to sine square plus cos square theta gives 1. So r square is x square plus y square, or we can say r is equal to under root of a square or x square plus y square. So it is modulus of given number which gives always positive value. So then this value of theta, equation of these, is called argument or amplitude of z. This is called argument of z. We can write this like ARZ z. Argument is what? Value of theta. Value of theta represent any complex number known as argument of that number, or we can say amplitude of that number. So if we talk about the theta, then what is our theta? Cos theta is x by r. Clear? R is under root of x square by y square. Then cos theta is x by under root of x square plus y square, and sin theta is equal to y upon under root of x square plus y square. So this theta is known as argument of given number, or we can say this is ARG z, and this lies between negative minus pi to plus pi range. Theta always lies between here to here. So plus pi minus pi to plus pi range. Theta is always, when we talk about this argument, it lies, the value of theta always lies between minus pi to plus pi. Clear? So next, now some examples for finding the modulus and argument of given complex number. How we find the modulus and argument of that complex number. I show you one example for this. If we have question, find 1 minus iota. Our number z equal to -1 minus iota. Find out the modulus, mod and ARG of z. Clear? So we can say -1 minus iota is equal to r cos theta plus I sin theta. Clear? Then theta is equal to argument of -1 minus iota. Clear? And what is modulus? Modulus is r square. So r cos theta, real part with real part is -1, and r sin theta is also minus of 1. Clear? Then r square is what? Under root of -1 square plus -1 square. Then r square is equal to 1 plus 1, or we can say r is equal to under root of 2. Clear? When we find out the r, then we can find out the value of sin theta and cos theta. So r is our modulus. R is root 2, one part is coming. Modulus of this function is root 2 value of. To find out the value, theta lies between. So now we go for theta. If we talk about the cos theta, then cos theta is -1 by r is root 2, and sin theta is also -1 by r is root 2. Clear? So sin theta and cos theta gives by -1 by root 2. Now we have to find this where it lies. So how we find out? See, if we talk about this number -1 comma -1, this is real part is -1, other part is -1. So this is 1, this is -1, This is 1, this is minus. So this number -1 lies here. So if we talk about lies here, so this is lies between -pi to -pi/2. Range between -pi to minus. So -pi theta, or we can say argument of -1 minus iota lies between equal to pi/2, negative of pi/2. Clear? So it lies between -pi to -pi/2. Now when we understand it lies between, then what is its unique value for this value? So what is its unique value? Minus of pi. This is minus of pi/4. So theta is equal to minus of pi. So minus of pi minus pi/4. So theta is equal to minus of 3 pi/4. So we can see here, if cos of -3 pi/4 gives this value, sine also. So that unique value is called argument of given number. So for given question, value of theta, or we can say argument z, is equal to -3 pi/z. So modulus is √2. So for finding any question, first we have to find out the modulus value, or then we go for the value of theta. I think that's all more than sufficient about the complex number. If we go further, then we move for de Moivre's theorem and all that thing for these complex numbers. So I stop my lecture on the complex number here. Thank you very much.